Okay, so we have S and T. They say are the x-intercept of the graph of f of x, which is given as ax squared plus bx plus c. They say a cannot be 0, which is not important. That says which is because if a is 0, it means it's not longer a parabolic function anymore. So it's a straight line if it can be 0, because the aggregate squared, any number multiplied by 0 is going to give us And then they say R is the y-intercept of f and g. And then they say the straight line drawn, the straight line through RT has the equation -2 plus D. And then 6.1, they say we should determine the value of D. Yes. And then as Dina was saying, she was trying to say, if we want to get D, we need to use G of X, which is the straight line. And I use T. And then because it passes through the point R and T, we can then use because T we don't have. Yes. So the only person that we can use is point T. So we can say T we have 6:0. And then what do we have? Then after that we have G of 6, which is going to be 0. When X is 6, our Y is 0. And then we can say which we have 0, which is going to be equaling to -2 multiplied by 6. Yes. Plus D. Yes, plus D. And then this one multiplied by this one, it gives us -12 plus D. Yeah, plus D. Take 12 to this other side, it says D is going to be 12. So because it's 2 marks here, we're most likely going to get a mark for substituting the 0 and the 6. And we're also going to get the mark for the D. This is a good examination question, just in case we don't get the equation again. So we know which we can proceed. So they say show that the equation of f of x can be given as -x squared plus 4x plus 12. Paco, can you take that one? Offense. Can you take number 2?
Yes.
So how do we do number 2, 6.2?
We are given the x-intercept.
Sure.
We are going to use the equation. To find the equation, we are going to use the formula A, open bracket.
So it says y is going to be A, open bracket.
X minus x1.
X minus x1.
Close bracket, open bracket, x.
X.
Minus x2.
Minus x2. Okay, sharp.
Yes. So we are going to look for a point to find A.
We're going to use, yeah. So which point should we use?
I'm still looking.
There's S.
Oh, S.
There's T. X1. X2. I agree that the x-intercept.
Yes. Mister, you know what I used?
Yeah.
I used, I found the point R.
Point R, yeah. What is point R?
Point R is, let me calculate. 0 is to 12.
Is 0 to 12. Yeah, it's here. Look at this. Agree. D is the y-intercept of the straight line. No?
Yes.
Yeah.
After that, I subbed y is equals to 12.
Okay, but I wanted us to first sub the x1 and the x2. Agree these are the x-intercept. Then because there's a mark for that. No?
Yes.
So we have A, we have open bracket, we have X. Agree it's minus, then it gives us +2. Ne? And then it says X minus 6, close bracket. Then they will give us a mark for this one first, ne? Substituting the x-intercept, yeah? And then you wanted me to sub the other point that you're talking about. It's...
Yes.
Okay. It says 12.
Is equals to
A.
Open bracket. 0 plus 2.
It's 0 plus 2.
Close bracket. 0 minus 6.
Okay. What do you get for this?
12. Minus 12.
You get minus 12A is equal to 12. No?
Yes. And you divide by minus 12.
divide by minus 12, divide by minus 12. It says A is
8
going to be equaling to
minus 1.
minus 1. Okay, we get another mark for here. So we're going to get a mark for subtracting the x-intercept. We get a mark for subtracting the 0 and 12. There's a mark for that. Ne? And then there's a mark for the
Yeah.
value of A. So all in all, now you have 3 marks. We want the last one. There are 4 all in all. So what should we do to get the fourth one?
Define the equation. We sub we're gonna say y is equals to
Y is equal to
minus 1 open
minus 1
open bracket
open
x
bracket
plus 2
x plus 2
x minus 6.
x minus 6. Okay. So we have
After
minus
that, we FOIL x squared
x squared
minus 6x plus 2x is equals to minus 4x
sure
negative 12.
negative 12. Okay.
Yes. Number
Okay.
we multiply by the negative on the
So we
outside.
multiply by the negative throughout. It gives us minus x squared. Ne?
Yes. Minus plus 2
4x.
plus 4x
Yeah.
plus 12.
Plus 12. Yeah, and then they will give us a
Yes.
mark also for foiling because they already told us this is the answer. So we'll get the other mark for foiling. Thank you, offense, for that one. Let's get,
Sir,
yes.
I did it in a different.
You did it in what way?
I firstly determined the x and coordinate of the turning point, then I differentiate, and then I the again, I differentiate the gradient of the turning point is 0. Then I differentiate the a the subject of the formula. Then I get the a the subject that go the I coordinate.
So, okay, let's compare the way you did it and this one. Which one seems to be simple?
This one is simpler, that's why I'm copying it.
Oh,
Yes.
yeah, because remember, we were given the x-intercepts here. But that one, I like it because, but now, I think we should differentiate also. Either we're given the x-intercept or even now cubic, because I would have said, let's use that one because it also works for cubic. Cubic, that's how we approach it. But
Yes.
provided we're not given the x-intercept. If we're given the x-intercept, let's go in this direction. It's the safest.
Okay, okay.
This is the safest. X1, X2. Remember, what is X1 and X2? X1 and X2 are the x-intercepts. Okay, let's bring in Ramatsat.
Big guns.
But I wanted to save the big guns for this question that we're doing. Ramatsat.
One. I'm gonna leave you now. Last a whole. No.
Bokamus wants to take it. Bokamus, take it. Calculate the coordinates of the turning point of F.
Maraweni awa. Okay. Sharp.
Yes.
So funa so verkisa le formula 18 xtp is equals to minus
X.
minus b over 2.
Can I ask us to do
Three,
this? I want, okay, but okay, XTP is equal to, yeah, minus
wait, let me minus b over 2a.
minus B all over 2A. Ne? And then guys, remember, this
Minus-
formula does not work on cubic. I've seen people when we're writing, they use this formula for cubic. So I wouldn't, that is why I would encourage us to use yeah, let's use the first derivative because it works here, it also works for cubic. But this one works for parabolic function, it doesn't work on a cubic. Do you still remember how to do it in the calculus, Bukamus Ristin? So that we practice using
No.
it. You don't remember. Okay, let's do it this way then.
Yeah.
So we have
Yeah,
X,
I am a
A is equal to minus 1.
Yes, and then
B is equal
minus
to 4.
oh,
C is equal to 12. Ne?
b is 4.
Is what?
B is 4 minus 4 all over.
So we have minus 4 all over 2 multiplied by minus 1.
Yes.
What do you get as X?
Is a 2.
It gives you 2. Ne?
Yes, and then mauteta uthatha le x, we substitute with the original formula.
So you say we got x is equal to 2, and then we should check, does it make sense? Ne? So you want me to say
Yes.
f of 2, ne? And I
Mm.
substitute it on this one here, which is going to be minus 2
Yeah.
all squared plus 4 multiplied by 2 plus 12. What
It's
did you get?
16. Why is 16?
You get 16. Ne? So it means what our TP
Yes.
is going to be equal to 2 is to what? Is to 16.
2 is to 16.
Okay, let's try it also this way, Bukamu, so that you remember what this one, this formula, it does not work with cubic, but this one that we're using, it works here, it also works with cubic. So if you want to get the turning point, we should remember that the gradient m at TP is equal to 0. And then remember what is m? M is f prime. The derivative is m. Ne? So we can use that into our
Yes.
advantage. So if we had to do it that way, let me do it with a different color. Usually read is best here. So we're going to have, if we differentiate this thing here, it says which we're going to have f prime of x, ne? Which is going to be equal to minus 2x ne? Plus 4.
Yes.
Ne? And then we say the derivative should be 0. At the turning point, this is only true at the turning point. So we have 0, which is going to be equal to minus 2x plus 4. Ne? And then okay. So we take the minus 2 to the other side. Ne? So if we take minus 2 to this other side, it says which we have 2x, which is going to be 4. Divide by 2, it says x is going to be equal to what? 2. So, but the way we get y is exactly the same in both cases. Which the way we got y before, and then the way we're getting y, this is going to be exactly the same. But I'm just saying, let's keep this in mind because it also works for cubic. When you get the turning point of a cubic function, you differentiate, you make the derivative to be 0. Sure. Okay, hot. 6.4.
6.4. Determine for each the values of x will. Number 6.4.1, they say f of x minus g of x be greater or equal to 0.
Sure.
So this is the situation whereby we must find the graph of f of x above the graph of g of x, so that f of x will be greater than g of x. I'm not sure if you understood what I said.
So we should take the g of x to this other side.
Yes.
So we have f of x, which is going to be, I agree the sign didn't change, the sign is exactly the same. So we have f of x, we have greater than equals to 0. Greater
to g of x.
we took g of x to this other side. Let's also take this opportunity to explain this. Guys, if I'm given g of x multiplied by f of x, and then they say it's greater than 0, I can't take anyone to the other side. There's no taking anyone to the other side because this thing here is one term.
Yes.
This one here, it's 2 terms. How do I know it is 2 terms? They're separated by a minus. So this one here, it's one thing because there's only a multiplication. I think that one is very important. So what are we looking for? We say we're looking for f of x. No?
Yes.
Where is greater than g of x?
Greater or equal to.
Greater or equals to. Okay, sure. So we need to go back to our graph again.
So we're going to do the metallo thing, anything.
Let me take it here. Okay, copy. Because we just need the graph now.
Yes.
Okay.
I can see it.
So let's take the graph here and just put it here next to the equation so that we'll see what we're talking about. Okay, so we have this. Okay. We need this only. Yeah. Sharp. Okay. I think we're good to go. So we want f of x to be above f of x.
Yes.
Okay. So we are going to do what?
We're going to draw, we're going to draw a line where the graphs are intersecting only. That's the only part that we need, where the two graphs are intersecting again. Because when they intersect, the one is going to change sides. The one is going to be above the other, and then the other is going to be below the other or something again. So we draw the line. The first line is on the y-axis, and the second line is on point T. Yes.
Should we make it like an asymptote? Will this help if we do it like this?
Yeah.
Demographic switch. Because they are not the line necessary.
Yes, yes.
Okay, so
Okay. So now, ladies and gentlemen, we're going to be looking for the parts whereby f of x is above g of x again. So as Mr. said, or f of x should be greater or equaling to g of x again. So not the only part that I see where f of x is greater than g of x. I get it. G of x is the straight line whereby f of x is the parabola again. So the middle part is the part that is f of x above g of x.
yeah, so we have three parts. We have a part before the vertical line number one. So it's this part here. If we highlight it, is this whole part here. This is part number one. So we'll call this one 1. And then we have another part, which is between the two red lines, is this part here. Then we'll call this one number 2. And then we have another part, which is after the red line, which is this part here. And then we'll call this one number 3. So Khozo is saying, if we look at number 1, the straight line is above. No? The straight line is above.
Yes, yes,
And
yes.
then g of x is what?
Is below.
So we don't want this one.
No, yes, yes.
We don't want this part.
This
so
part we don't want
we
it.
don't need it.
Yes.
And then we go to part number 2 now. We're done with part number 1. If it didn't work with part number 1, it didn't work everywhere.
1 and 3 and 5.
So now we're going to have part number 2. Part number 2, you say this one is above. No?
Yes, which is what we want.
This one is what it's below.
Below.
Okay. Then you check what is x here. Let's tell them what is x here.
0.
It's 0. What is x here?
6.
It's 6. So when did this happen? It happened between 0 and what?
And 6. And 0 and 6 must be included because they say that they should be greater or equaling to each other.
So we have 0. No?
Yes.
And then we have x is going to be greater or equals to 0.
Yes.
But x is going to be less or equals to what? To
6.
Or I prefer to write it this way. X is an element.
Okay,
Square bracket.
Yes.
From 0.
Yes.
So until we get to what?
To 6.
Does it make sense?
No, please repeat.
You want us to repeat this, Bukamuso? Bukamuso,
Yes.
we want f of x to be above. We want g of x to be below. Ne? That's what we mean here. Remember? The only reason why I was able to do this is because there's no multiplication. So I have f of x minus g of x is greater or equals to 0. So if I play around with this thing here, it's just like an equation. If I play around with this thing, it says I should take the g of x to that other side. So I have f of x, which is going to be greater or equals to g of x. So that's what we have. So what does this mean?
Yes.
Greater than, it means with this one is above. That's what it means. Yeah? And then this one, it
Yes.
means this one, if it's less than, it means with this one, it's below. Rapelo was saying below 0 yesterday. It was Saturday. So, where are your changes going to happen, Bukamuso here? Your changes, because we're comparing two graphs above and below, they are going to happen at the point of intersection. So at the point of intersection, you're going to come and draw a vertical line. Why a vertical line? You want to know what is x there. If I draw a vertical line, it tells me about x, doesn't tell me about y. So what is x here? It says which x is going to be 0 here. This is the point of intersection. Yeah. And then I'm checking again, where else do I have a point of intersection between these two graphs? The other point of intersection that I have is this one. Yeah, and then I'm going to also again draw a vertical line. And then I tell them which x here is going to be equal to what? To 6. It's fine. So now that you have your vertical line, we call them critical points. These are your critical points. This is what you're going to be checking. So you have this part just before the red line. The red line is your critical point. It's where changes are going to be happening. So you need to know where your changes are going to be happening. So your changes are going to be happening here, number 1. Now, if you check here with the green part that I just highlighted, you check g of x. G of x is the straight line is above. If you are to draw a vertical line, you will see if you draw a vertical line, which one did you start touching first? You started touching g of x before you touch what? F of x.
F of x.
Yeah, so this one is above, but this one is what? It's below. That's not what we want.
Below.
We want f of x to be above, and then we want g of x to be what? To be below.
To be below.
Yeah, so this one does not work. We cancel it, this one. So this one, we cancel it. It doesn't work. But if we check here, between this point, if you check this part here, if I say this is green, f of x is green, the green part is above, f of x is below.
Below.
Yes. And then up until we get to what? Up until we get to 6 here. Now this thing here can be extended. This one doesn't have to stop there. this thing here so that you'll see it. Okay, it took this one. Okay, if I were to extend this one here, it's extended. This thing here, it's continuing. If you check here, this one is above, but this one here is what? It's below. That's not what we want. We want F to be above, and then we want G to be what? To be below. So this one didn't work. So which one worked? It's between 0 and 6. That is why the vertical lines were helping us. How do you write something that is between 0 and 6? Mathematical. You can say X is going to be greater than 0. And then you're also going to tell them which X is going to be less than 6. Or if you don't want to write it that way, you can say X is an element from 0 up until we get to 6. But 6 is included and 0 is also going to be included.
Oh, yes.
All right. Rapela, do you want to take this one? Or Chairman? Or anyone?
Or Ramatat.
Ramatas, do you want to take this one?
No, sir.
You don't want to take it?
So,
No,
so
let's erase this one. We are done with f of x, g of x.
yes.
Okay, let's deal with this one. Sure.
So more 6.4.2, I'm going to say what mistake really said go Saturday. So Mukivar x multiplied by f of x should be less than 0.
Okay, let's
So-
write it down. So it's x multiplied by f of x.
Yes,
It should be
less than 0.
Okay.
So he saw x, it represents the x, the Cartesian plane of x, which is the x-axis.
Okay.
So this situation, x are not even negative, and then f of x are not even positive.
So we can either have negative this side and then
Yes.
this side we can. So for us to have something which is less than 0, Rapela is saying we can either have negative multiplied by positive, which is going to give us what? A negative. It's less than 0.
Yes, yes.
That's one way. Let's make the other one blue. Yeah. Let's use these two. Sure.
Yes, and the other way, regard have a positively and negative, which is really
We can have positive this side.
yes,
And then we can have negative this side.
yes,
Then it will give us what? Negative.
negative.
Okay,
Sure.
sure. So we take red as negative. Mike.
Yes, yes.
That's
yes.
how we're going to represent red.
Yes. So more similar my graph yeah.
Let's start with x because it's the first one. Between the
Yes.
two of them, x is the first one.
Yes.
So
So
let's check where x is
is negative.
Yeah.
Yeah. So below 0, which is this part, the left side, it's negative.
Yeah. Again, if you draw a Cartesian plane, this is 0.
Yes.
If you go this side, you're going towards the positive side of x.
Yes.
If you go this side, you go towards the negative side of x.
Yes.
So x is negative.
Yes.
And then here, we are going to draw a dotted line to represent what there's a change which is happening for x. This change is for x. No? This is a change for x. Sharp. And then after that, we said blue is positive.
Yes.
So you can come and say positive. Sharp. Okay.
So muke wanang mo f of x aga ileng positive ke no tloa mo r mo s ho ya ko r. My f of x is positive, it's increasing.
No, we're talking about if we're talking about f of x, we're talking about y.
Yes,
So
yeah, the y value.
The y value,
Yeah.
it's either is appearing above the line
Yeah.
x-axis, this one.
Yes.
So if it's appearing above the line, we say it's positive.
Yes.
If it's appearing below the line, it's what?
It's negative. So
Okay, let's represent the negative with the rectangle, like
Yes.
so that they're consistent.
yeah.
So we have negative.
Yes.
Up until we get here, there's a change.
Yes,
here.
yeah. Where was
Okay,
it?
and then we draw a vertical line.
Yes.
A vertical line.
Logo T.
Okay, and then after that, blue color is positive.
Yes.
So this graph here is appearing above the x-axis, so it's positive. It's positive.
Positive. Yes.
Positive. I don't know why when I get this side, I make my positives to be ugly. Okay, so it's positive. It's positive. It's positive. Yeah, I'm not patient.
Yes.
I want to finish. So
Then at
we get
T,
here,
yeah, it's
and then
negative.
we draw another vertical line.
There's a change.
Guys, do you see the changes that we're talking about, man?
yes, sir.
Yeah, because the graph is changing from being positive to negative. Then you need to draw a vertical line to say there's a change that happened. Then
Say,
yes.
can you repeat?
Can I repeat the change?
Yes.
Yeah, if you look at this graph of f of x, it's below the x-axis, meaning which is negative. The graph itself, it's negative. So the way it works is like this. So you have your x-axis. If I have a graph like this one here, and then they ask me where is the graph positive, where the graph is negative? It's negative below the x-axis. So here I would say it's negative, 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 negative. Above this line, it's positive, 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 positive. And then below the line again is negative, negative, negative. Is it fine, Kineil?
Yes, sir.
Or should I repeat some more?
No.
It's fine. Okay. So now that you have this, you can go and work now. Here's what we're looking for. We're looking for, on our demographics, we have just before red. Yes.
Yeah, more reliability, more.
Maybe let's highlight them. So we have this part here.
Yes.
This is the first part.
The first part, and then the second part.
And then we have the second part.
We have the third part.
We have the third part, which is between
Yeah.
blue, red and blue.
Yes.
And then we have the
fourth.
after blue.
Yes.
I should have used different colors, but it's fine. I think we get the idea, which we have 4 different parts.
Yes.
Okay. So we're going to look at part number 1.
Yeah, part number 1 is.
Maybe let me ask, Kineil, let's look at part number 1. Can you see part number 1 here?
Yes.
Let's look at this thing here. X-axis. What color do you see there?
Red.
Huh?
I see red.
Let's look at this graph here of f of x. What do you see? Which color do you see?
Red, sir.
Yeah, so it's red and red. We don't want red and red. Now we want red and blue. Ne?
Yes.
So this one didn't work. We cancel it.
Yes.
Because now what are we looking for? We're looking for red and what? And blue. Let's go to part number 2. Part number 2, it's here. You see this part here? Okay, let's continue. So you have part number 2.
So yeah, part number 1, we see negative, and that doesn't apply to our scenario. So it's automatically out. So what the parts say, if I show our examination. Okay. Continuing forward, we are going to use part number 2. So part number 2, we see blue and red. So this blue and red, it qualifies for our.
Okay. Part number 2, yeah.
So part number 2, it qualifies for our scenario because we could see positive and a negative, and that will automatically give us a negative. Okay. So we are going to say x is an element from.
So we want x to be an element from
-2
to
0.
Not included, both of them.
Not included. Okay. And then we have another part if for or to just extend the answers.
Okay, here we have blue and blue. We don't want.
Yeah, we don't want that.
Okay, so here we what happened? Did you cancel this one?
No, we didn't put them.
I didn't put them.
The negative letters, yeah.
Okay, so put them just after 6. No?
Yes. So at t we have negative and positive.
Yeah.
So you want x to be greater than 6.
X to be greater than 6.
Yeah.
So you get 1, 2, 3. Yes. We'll get 3 marks. Did it make sense there, guys?
Yes, sir.
It did make sense. Eh? Remember, for you to make your life simple, you should.
Negative 2.
To make your life simple, you should make the demographics. Wait, are you saying something? Wait.
Sir.
Yes.
We are thinking about 6 here.
We are thinking about
6.
We are thinking about 6.
X is, oh, you said x is greater than.
Yeah, this one, the x is positive, but the graph is below the x-axis, which is negative. That's this graph.
Yes.
All right, let's do the last one. It says determine the coordinates of R, the image of R on P. If P is equaling to, so what is going to be R prime is the image of R. Ne?
Yeah,
which is I think I look, it seems as if it's a reflection, and
yes.
then it's also shifted 2 units. Well, let's check R is what? I think R was the y-intercept.
Yes.
So we affect X. We're shifting the X 2 units, no? Plus.
Plus, yeah, it's going to
Yes,
be
it's
plus.
going
Now
to
it
be
is
going to be plus.
negative.
So what is going to be the new point? We expect it to say we have plus 2, no? Minus 6.
Let's say
So, Mr. Ne, ingawa wrong nane, momo f of x, you can put a negative kamundi. If it's a substitute x minus 2, if it's a kind of the derivative, you're doing r prime or.
They didn't say, oh no, they just said this is just a coordinate of R, like it's like R is an image. We just say R is an image. So
So
we
you
didn't
want
want to
the-
call it R, we just call it R image. I like that this means R image. And
So,
then remember, I mean, that is what I'm thinking. I'm not sure, but we'll advise each other. I get it's 2 marks this thing. We shouldn't waste our time on 2 marks. So we are saying we have f of x. If we write it in a turning point form, remember, we can write it in a turning point form, which we don't need because that's not what we're doing. Okay. We want to reflect. Let's go to point R. What is point R original? Point R original, it's
was.
oh, it's 12. This thing.
just 12.
Oh, okay. Sorry about that. It can be 6. It needs to be minus 12. Needs to be minus 12. Okay, so I agree we had 0 is to 12. So what kind of transformation did we have? Number one, we see a negative. If you see a negative, it means this thing was reflected. Okay? But the other thing that we also see
Okay,
is
sorry, sir. Let's go back to the question first.
Mm.
So whenever the image of R on P, they mean that it lies on P or it was reflected by P.
no, I agree. P it's a new equation. Yeah, this is a new equation, which is P. It's like
Yes.
P of X. So this new point is going to lie on P of X, which is it's like saying the reflection. H of X is the reflection of F of X by the X axis. So H of X is the new equation. But how do you get H of X? You get
Yes,
H of X by reflecting this thing by yeah.
I get it.
So I'm thinking to myself, if we are not lazy, we can try to do it. I agree we have F of X, which is equal to, I think it was minus x squared plus 4x plus 12, something like this.
Yes.
So if you really wanted to try it, maybe you could have said, okay, let's change this. Because this is negative,
Yes.
and then we shift this thing. Then we shift this thing. If we shift this thing, and then it says which basically we are shifting it. I agree it's minus. If it's minus, it means which is a plus.
Yes.
So instead of having 0,
Which one is all we can?
oh, instead of